No, I cannot share the screen. I think host is disable the participant screen sharing. Can you enable that?
Sure, we will.
Good evening, sir. Let's start the session today. So, good evening, ladies and gentlemen. Hope you are all staying safe and well in these troubled times. I am Janaka Dantanarayana and I'll be your host this evening. I welcome you all to the second episode of Inven organized by the Electrical Engineering Society of University of Moratuwa in collaboration with the Undergraduate Inventor of the Year Committee of the Institute of Engineers, Sri Lanka. Let's have a small recap on our last session. As the first phase of Inven, we, as the Electrical Engineering Society of University of Moratuwa, have organized this Tech Talk webinar series in collaboration with the Institute of Engineers, Sri Lanka.
Inven is a newly initiated concept which is focused on sharing industrial experiences, expertise, and exposure of middle-level field engineers. Today's topic is building the future, starting from Sumrita's beauty. We are hoping to discuss about the process of evolving from being a graduate and engineer, the essentials and challenges, and how to prepare as undergraduates to reach the global stage in engineering.
Electronic applications, based on some of my experiences. The first one is marine propulsion and electrification of marine systems. And Siemens Norway holds the global responsibility for low voltage DC distribution systems. It is called Blue Drive and Blue Drive Plus C. These are the product names. And it's a very profitable business. And it is low voltage, 1000 volts DC. And this is the DC bus bar. Not only that, beyond that, you can even shape the future of the global trends, because you are sitting in a very powerful place.
But the motive is to share the industrial experience and exposure for the young blooming engineers, and which engineers promoting creativity, soft skills, and inventions and innovation, which drive for the apparently the entrepreneurships as well.
We, as the next wave of engineers in Sri Lanka, have had education from our schools and universities. But education itself is not sufficient to go towards success. We need to build up our skills to meet the timely requirements of the industry. The skills that were essential in 50 years ago may not even be a requirement today. So we have to create a bridge between the engineering industry and the undergraduates. With this goal in mind, Inven was conceptualized for sharing industrial experiences, expertise, and exposure of the professionals in the engineering field, with undergraduates while promoting creativity and required soft skills to make us ready for future challenges. This time, we are exploring about engineering project designing, planning, executing, and commissioning. So in order to welcome you all to the second session of the Innovations webinar series, I cordially invite my fellow undergraduate, Lakshani Patirage, on behalf of the Electrical Engineering Society of University of Moratuwa. Lakshani, over to you.
Yes, thank you, Janika. Good evening, everyone. On behalf of the Electrical Engineering Department and Electrical Engineering Society of University of Moratuwa, first and foremost, I would like to warmly welcome our today's session guest speaker, Engineer Dasun Arandarage, Engineer Nawudine Kankanamge, Dr. Rasara Samarasinghe, and Dr. Tushara Damayanti. Next up, I warmly welcome everyone from the IESL and Electrical Engineering Department who participated with us today to make this event a huge success. Inven is a newly initiated concept which is focused on sharing industrial experiences, expertise, and exposure of middle-level field engineers with undergraduates while promoting creativity, required soft skills, innovation, ideas to make us ready for future changes with the aim of bridging 2 decades. Today's topic is engineering projects, designing, planning, executing, and commissioning. It's a very essential and a much excited topic for all the undergraduates out here. As we all understand, this is a beneficial and a noble opportunity for us as electrical engineering young undergraduates. Finally, I would like to say, listen carefully and grab the best out of best from Innovation, second episode. Stay tuned with us for many more. Thank you. Over to you, Janika.
Thank you, Lakshani, for welcoming us. Next up, when talking about the engineering industry, there is one institute in Sri Lanka that we cannot forget. That is the Institute of Engineers, Sri Lanka. To represent this pioneering institution, I invite Chief Engineer at Ceylon Electricity Board and Council Member of the IESL, Engineer Nawudine Kankanamge, to address the audience. Dear sir, the stage is yours.
Thank you very much, Missy. Inventions doesn't happen overnight. Invent of the year program and undergraduate invent of the year program are major events that IESL conducting for promotion of inventions and innovation in Sri Lanka for decades actually. Currently, we started Invent Ovation, a series of discussions with the mindset of engineers towards out-of-box thinking while exposing to industry experts. If there is any gap between you and the fresh graduates are weighted by the industry, probably this would be a good forum to fill up that gap. This is the second episode of the Ovation series. Special thanks goes to you and IESL UIY team for organizing this. Without taking much time, we will move to the key speaker today while thanking you all for joining with us this evening. Thank you. Over to you.
Thank you, Nawadana. Janak, are you saying something? You're on mute.
Thank you, sir, for reminding me. The main event of the day, of course, our guest speaker. He's an electrical engineer who graduated in 2008 from University of Moratuwa. He's also an associate member of the Institution of Engineers, Sri Lanka. Currently, he is employed by the DMO Private Limited and has been there for the past 13 years. So without any further ado, I warmly welcome our honored guest speaker, Engineer Dasun Arantarage, to Innovation's second episode, and I invite you to introduce us to the engineering project designing, planning, executing, and commissioning, and how we should prepare for the future. Yes, sir, the stage is yours.
Thank you, Janaka. Thank you very much. Thank you very much for the lovely introduction. And I would like to thank Nawadana and Dr. Asara also getting me involved in this wonderful session. I'll first try to share my screen because I have prepared a small presentation. I hope my screen is visible.
Yes, we can see.
All right, okay. Okay, so before I start this today's session, I would like to tell you now, when Navodhan asked me whether I can do a session to the undergraduates, I asked, what is the objective of this session? What should be the core of my presentation? What would be the core of my delivery to the undergraduates? What I heard from them is, okay, the undergraduates, they want to know about the opportunities in the industry and what exactly the industry expects from a fresh graduate. Of course, when I was also an undergraduate and a fresh graduate in 2008, I was also wondering what exactly I can do using the knowledge I have gained in the university. So using the experience that I have gathered so far in this industry for more than 13 years, I'm going to show you what are the job opportunities you have in this industry and what exactly we expect from a fresh graduate. I'm not going to do a technical presentation on designing, planning, executing, and commissioning because I'm not an expert to all these things. And I'm pretty sure that you have been hearing a lot of technical sessions in the university and you want me to give something else, something from the experience that we have gathered from the industry. So I will try to confine my speech to power sector because that is the industry where I have gained my experience. So if we talk about the Sri Lanka power sector, apart from the consumers, these are the key stakeholders, and out of these stakeholders, utility is the key stakeholder in this industry. That is Ceylon Electricity Board. The entire power industry is concentrated on CB in Sri Lanka because they are the sole utility in Sri Lanka. Then apart from the utility, there are so many other organizations like funding agencies like ADB, JICA, AFD. So these are the foreign funding agencies. Apart from them, there are local banks as well, like People's Bank, Bank of Ceylon. They also fund for this type of projects. And the other key stakeholder in this sector is contractors. There are engineering companies, foreign companies, local contractors, and there are consultants, foreign and local consultants, and there are so many equipment manufacturers and their agents, their dealers also involved in this sector. At the same time, service providers like maintenance service providers, testing commissioning service providers are there. And developers like power plant developers, also a key stakeholder in this sector. And then comes the regulator, the Public Utility Commission in Sri Lanka, as well as the Ministry of Energy. So these are the organizations where you can, these are the organizations who provide job opportunities to the industry in power sector. Here I have shown you the current power system in Sri Lanka. You might know that, okay, Sri Lanka currently is 99% electrified, only few to be electrified. Then why there is a requirement of such lot of organizations? What is the requirement of having such organization if there is no development? It's no. There are a lot of development even though the country is electrified. This network is so dynamic because every year, every day, there's an increase of power demand. Every year, around 30 megawatt to 50 megawatt of power increase is there, power demand increase is there. And not only that, we want to move for renewable energy. We want to move for clean energy. So to absorb those energy to the network, there should be a lot of developments in the network. And at the same time, loss reductions, because there are considerable losses happening in the network. So to reduce that loss, there are a lot of projects are happening. And stability and reliability improvement. You know, few months back we faced a blackout in the country. So these things should be analyzed, studied, and then amendment to the system should be done so that such situation will not repeat again in the system. So if there's any human error, if someone can do a human error in the system, still the system should be reliable so that the entire system should not collapse. That is what exactly happened a few months back. So these are the developments that has to that has to happen in the network. So every year there are around $100 million of projects happening in the industry. Ceylon Electricity Board, they invest, they borrow money from foreign funders, funding agencies and local funding agencies. At the same time, government of Sri Lanka, they fund for these projects and they keep on improving the system, this power system in Sri Lanka. So let's discuss how such projects are initiated and implemented in the industry. So it starts with the planning of the power system. You all know when the demand is increasing, you have to build power plants. And building a power plant, a major power plant, is not a single year or a 2-year job. It will definitely take at least 5 to 6 years. Construction itself will take 3 to 4 years. And to do the planning and the procurement part, it will take another 2 years. So if we have to increase the power generation, we have to think today to build a plant in another 5 years. Without planning, then this will be a big problem. You should know what is going to be the demand in 5 years. At the same time, you should plan to build new power plants to cater to such demands. Not only that, there are new technologies coming to the industry. Renewable energy is getting cheaper. So we have to think of retiring our old power plants, which are not as clean as renewable energy. At the same time, increase the percentage that is fed by the renewable energy. So Ceylon Electricity Board, they prepare their 20-year generation plan, which is reviewed in alternative years. Every 2 years, they review their generation plan and they get it approved by the regulator, which is the Public Utility Commission. And once that is approved, you have to prepare your transmission plan that they prepare for 10 years. And the same is reviewed in 2 years. Parallelly, the distribution is happening in several, not in centralized manner. They do the distribution plan in different regions. So first, let's take how this generation is planned. As I said earlier, the planning department in Ceylon Electricity Board, they plan their generation for next 20 years. This is the generation energy mix that they have planned for next 20 years. You can see how the oil is going to reduce, how the other renewable energy is coming to the picture, and how the natural gas combined cycle is coming to the network. So this is the one of the major activity of planning engineer in the planning department of the Ceylon Electricity Board. And once they identify, okay, these are the power requirement and this is the power mix, then they define, okay, what are the new power plants? What are the renewable energy additions? Now in 2020, they were planning to build a solar 100 megawatt and wind another 20, mini hydro 15, biomass 15, and thermal addition of 145 reciprocating engine power plants and 200 megawatt short-term basis power plant and 100 megawatt short-term basis supplementary power plants. So likewise, for next 20 years, they have planned what are the plants that is going to be connected to the grid in coming years. So this is the major part of a planning department in the Ceylon Electricity Board. Once the generation plan is fixed, then they do the transmission plan. They know how to forecast based on the government policies, based on the new developments, where are the new loads going to be and how the existing load going to increase. So based on that, they design their transmission plan, they design their transmission network to cater to those increasing demand. At the same time, they prepare their network to absorb those power generation to the network, and loss reduction, renewable energy absorption, and reliability and stability improvement. So they define, okay, these are the projects that are going to happen in coming years. So I have listed out what are the tasks of a planning engineer and what they do when they are in the planning department. The first thing is they do system modeling, because you do this in your universities also. You have to put all the system into a paper or a design. Now we are not putting into a paper, we are just putting into a softwares in the computers, and we model the entire system. If there's a change in the system, that we have to update in the system that we have modeled. And load forecasting based on the government policies, based on the new the development projects, based on the new renewable energy developments, you have to do the load forecasting, and that is one of the key tasks for planning engineer. And once all these are done, they prepare the long-term transmission and long-term generation development plans. Once both the generation and transmission plans are approved, then they start the project initialization. So they know, okay, what is my next priority based on the current load and the load that they are expecting in another 2-3 years. What should be my priority list? What are the projects that I have to take funding arranged? So they identify those projects in the transmission development plan, and they should arrange the funding through the funding agencies like JICA, ADB, World Bank, AFD, or local banks. And once that approval, once that consent is received from the funding agency, then they have to do the preparation of preliminary tender documents. They have to outline the project's requirement, and then they give it to the next level, next phase, which is the design phase. They give it to the design department. Apart from that, there are special studies that planning engineer has to do. Some few years back, there was a discussion to connect Sri Lanka and India through a 500 kV DC link. When such a new proposal comes, the planning engineers are there to study that proposal. Okay, how that going to affect the network, how we should improve the stability, how we should strengthen our network to accommodate such proposal. So such type of special studies is carried out by the planning engineers. They use a lot of software tools, because nowadays there are a lot of powerful softwares which has made the planning engineer's life easy. PSSE and PSCAD are two of most powerful softwares that they use to study the power flow, short circuit level studies, transient stability, because you cannot do these things on a paper for such big system. So planning engineers, they have to use these softwares and do those studies. To carry out these activities, there are a set of skills and knowledge required to become a planning engineer. First thing is power system knowledge. In your universities, you study these power systems, right? That knowledge is really important to become a power planning engineer. And also soft skill like analytical skills, attention to detail, because if you miss something, the entire power plant will be a mess. So you have to redo. So attention to detail is really important for a planning engineer. And again, the team working skills, because not only there's no single person working. It is a team that they work. There are a set of engineers working different sectors of the power system, and they work together to develop the entire generation and transmission plan. And as I said earlier, there are a lot of softwares that they use, so you have to be computer savvy. And always communication skills is a must. It does not mean that, okay, English is required. Yes, English is required because that is the common language that we have to use with other foreigners. But there are nationals like Japanese where they support us to do a lot of planning and funding, like JICA and Japanese funding agencies. They are not even as good as us. But using the communication skills that you have to present your proposal and get their consent for your proposal. So those are the key skills and knowledge that we expect from a planning engineer. So if you are planning to become a planning engineer, think of these things. It's a really good job. You have a lot of technical exposure in that. Right, then I'll move on to the next area, which is the design part. Once the initial design is done by the planning engineer, they outline the requirement, then it is given to the design department, be it a substation or a transmission line, power plant. It's the responsibility of a design engineer to do the design of that. There are a lot of previous design that they have done. Using those designs, they prepare single line diagrams and they design what is the requirement of equipment and subsystem, and they define the sizing of those equipment and subsystems. Equipment like transformer, equipment like circuit breakers, current transformers, voltage transformer, disconnectors, bus bars. So they design that systems and they define the parameters of such equipments. And once these parameters are defined, then they do the layout design. How the layout should be when if they are designing a substation, how many bays are there? So how are we going to accommodate such bays in the substation? And how are we going to accommodate future requirement to connect future new lines to the substation or new transformers to the substation? I'll just show you one tender document which we have received very recently. which was designed by the engineers in the engineering department. Can you see my screen, a single line diagram?
No, sir, we still see the PowerPoint presentation.
I hope you can see in my screen now.
Yes, sir.
Right. So this is the single line diagram of a substation that we have received recently. I will just zoom one way. You can see this is the Ambalangoda line bay, and you can see the surge arresters. They have defined the voltage level, the class, the disconnector voltage level, current capacity, short circuit capacity, and the current transformer. What are the ratios? What are the classes? And the circuit breaker, what is the current capacity and what is the short circuit capacity. So likewise, they design this substation, and they do the sizing of the equipment and systems. So this is how they do the single line diagram. I'll just show you a layout design as well. Okay, so this is a layout of a substation. So they have placed the transformers and the other equipment in the substation, and they have prepared this layout. So it is the responsibility, it is the task of a design engineer to do such a layout design. I will once again go to my presentation. Okay, once the layout is done, then it is the responsibility of a design engineer or design department to identify the proper lands for such requirement, and then prepare the bidding document. Bidding document is the tender document which they put their requirement into words and drawings. So they have to prepare the specification and the initial drawings of their requirement. Then once this is done, then they hand over this document, this project to the project management unit. Then once the project management unit call the bids from the contractors, and again design engineers, they involve in bid evaluation. And once the implementation of the substation or line or of the project is started, then once again they involve with the design reviews. So to do those activities, these are the knowledge and the set of skills . Sorry, before that, to do such activities, just like the planning team is using a lot of software tools, these design engineers also use a lot of software tools like Silent, ETAP, AutoCAD to design the power flow, short circuit, impedance analysis. they also use this type of softwares rather than doing paper calculation. And AutoCAD, they use to do the single line diagram, layout, and SAS architectures. To do such activities, for a design engineer, the knowledge about the power system and the knowledge about power system protection is really important. These two things you learn in your university. So those are very important for a design engineer. And again, there are a set of soft skills like analytical skills, attention to detail, working with teams, computer knowledge, and also communication skills are really important for a design engineer. And as I said, once they do the initial design, then they hand over this to the project management unit in the organization. There are project managers, there are project engineers. In project engineers, there are electrical project engineers with the electrical background and project engineers with civil background. Okay, and once the design team gives the document to the project management team, they have a task to prepare the tender document, compile the tender document so that they call tenders from EPC contractors or other contractors to develop that project. So once they publish the tender, they call for meetings and site visits, and they tell you the requirement of their project, and they show the contractors the sites and the requirement, which the development that they want to do in those sites. Once those pre-bid meeting and site visits are done, they have to prepare the responses for the bid clarifications, because the contractors, they go through the tender document that prepared by the design team and the project management unit, and they raise different questions, and they send it to the project management team. So you have to prepare the responses for those clarifications, pre-bid and even after closing of the bid as well. Then once the bid is closed, once the bids are submitted by the contractors on the deadline, the evaluation of the bid has to be done as per the procurement guideline. That will be done by the project management unit, project management team with the support of technical evaluation team. Once that part is done, they award the contract, they award the project to a contractor. And once that project is being awarded, once the project started in the site, you have to do the site supervision, design evaluation and coordination, because there are a lot of designs has to be done by the contractor and submitted to the project management team. So it has to be evaluated by the design team. At the same time, it will be evaluated by the project management team, and that will be coordinated by the project management team. And at the same time, project progress monitoring and evaluation. And once the project is completed, they have to hand over this project to the operations and maintenance team. So that is the part of the project management team of the client, Ceylon Electricity Board. Parallelly, there are contractors who are working on securing these bids. I represent basically this sector, because we are bidding for the project requirement of Ceylon Electricity Board, and then we develop those projects. So there are few tasks of bid preparation team of a contractor. Contractor's bid preparation team, the most important thing is the customer relationship management. You have to maintain a very good relationship with your customer, which is the project management team, design team. Otherwise, you'll not be able to do this project properly. Before you securing this project, when the tender is published by the project management team, you have to analyze the tender guideline and specification, collect the visual data during the pre-bid meeting and site visit. When you go to the site first day, you have to take the measurement at site, and you have to analyze, okay, how we are going to do the development. There will be land filling, and there will be piling in the site. So such type of information you have to gather during the site pre-bid meeting and the site visit. And there are a lot of heavy equipment we have to bring down to site when the project is being implemented. Heavy equipment like transformers, which is more than 50 to 60 tons weight. So when you are transporting such heavy equipment, you have to analyze whether we can transport those equipment from the road, whether the culverts are strong enough to bear that weight, whether the road crossings, whether the bridges are strong enough to bear that weight of the heavy equipment. So such type of analysis you have to do before you submit your bid, because most of these bids you are responsible for entire project as a turnkey project. So once the bid is floated, if there's any ambiguity in the specification or the bid document, it's the bid preparation team's responsibility to call clarification from the client project management unit. We have to send the written clarifications to the project management unit. And once we get those clarifications, and using the existing data in the tender document, we have to request for quotations from original equipment manufacturers like transformer manufacturers, circuit breaker manufacturers, bus bars, disconnectors, CTs, VTs, CRP, control relay protection, GIS, AIS equipment. So there are a lot of equipment manufacturers across the world. So you have to call quotations from them and see whether their products are meeting the criteria of the clients, which is defined in the tender guideline. So at the same time, you have to do a preliminary design and do an estimation to bid for such projects. If you bid a wrong price, either you will lose your money, either you will lose your project, right? So it is really important that you do a preliminary design before you bid and do an estimation. And you have to do negotiations with OEMs, original equipment manufacturer, and subcontractor to get your price optimized so that you win that project. And once you submit the project, once you submit the bid to the customer, the project management team of the client, they will ask various questions on your submission. And we have to send those response to the project management unit. We call it post-bid clarifications. So these are the activities that is being done by the bid preparation teams in the with the contractors. So these are the most important set of skills for a bid preparation team: leadership skills with PR, communication skills, attention to detail, negotiation skills, and time management. Negotiation skills is really important to make your bid with to get your price to the winning prize and the time management. Because always, just like you do the courseworks in the university, there's a deadline to submit. If there's single second pass, then your bid will be rejected. So time management is really important. So these are the set of skills which is important to become a bid manager or a bidding engineer. Then once the project is secured, once the project is awarded by the project management unit of the client to the contractor, then the contractor also set up a project management unit under them. They appoint a project manager, they appoint different project engineers, quantity surveyors, consultants, safety engineers, so that they can execute this project and commission and hand it over to the client. And that PMU, the project management unit task is to do the detailed design of the project and finalize the original equipment manufacturer and subcontractors and do the procurement part. Then parallelly, they have to do the site planning and start the site activities, constructing the foundations, the buildings that is defined in the contract. They have to control the budget and time because all the project is awarded with a fixed budget and fixed timeline. So it is the PME project management team of the contractors. They have to control their budget and manage their time so that they deliver the project on time. At the same time, they have to implement the health and safety procedures so that they safeguard all the environment as well as the client's property, your own property, your own employers, and the client's employers and other public when you are implementing this project. Then you have to do the construction planning, follow-ups, progress reviews, and monitor. Then ultimately meeting the customer satisfaction by delivering the right project on right time. To do that, there are a set of skills required for become a project engineer and project manager. Strong leadership skills are really important for a project manager or a project engineer. Otherwise, you'll not be able to deliver the project requirement on time. And there are a lot of communications happening between the client, consultant, subcontractor, your own management, and your vendors. So communication skills are really important for a project engineer or a project manager. And again, the negotiation skills. You have to negotiate with your vendors, with your manufacturers, otherwise you will not be able to generate your profits. And you have to manage the risk, do the risk management, and at the same time management. So these are the skills that we expect from a project engineer and then a project manager. Then when it comes to the final stage of the project, we have to do the testing and commissioning and hand over the project to the customer. So it is the task of the testing and commissioning engineers to do the pre-commissioning and prepare the system for the commissioning work. So they do scheme checking, they go into details, they do the point-to-point testing, whether the the wires, even the wires are connected the right place, and they do the point-to-point testing and loop test, whether everything is in line with the requirement of customer. Then internally, we do a functional test, whether the products are working properly. And then in front of customer, we commission the equipment using the commissioning, recommended commissioning methods by the original equipment manufacturer or the other standards defined in the contract. So to do those testing and commissioning, testing engineers, they use a lot of equipment to test those equipments. There are primary and secondary current injection kits. So these are the kits that we use to test relays, whether the relay is functioning in the right current and right time. We use secondary current injection, and we use the primary current injection to see the test the CTs also, and then circuit break analyzers, CTVT analyzers, CRM test kits. CRM is contact resistance measurement test. Then the insulation resistance test, tan delta to test the insulators of transformers, SFRA test to test the mechanical suitability of the transformers, and BDV test, breakdown voltage test for the oil of transformer, and winding resistance test. So these are the testing tools that we use when we do the testing and commissioning of a substation. So testing commissioning engineers, they should be really thorough with the power system protection knowledge, and they should know the specification thoroughly as well as the standards. For them, analytical skills are really important, and attention to detail. There should not be anything they left out, because if they do the testing improperly, then there can be a serious problem in the system. And at the same time, they have to work as a team. When a big substation is being commissioned, a lot of testing engineers will be working parallelly to commission the station. They have to use a lot of software tools. So computer knowledge, computer literacy, and communication skills are really important. So these are the job roles that we usually come across in this power sector projects: planning, designing, executing, and commissioning. You might have seen there are a set of common skills that is required for any engineer, which are team working ability, leadership, communication, analytical skills, attention to details. So these are really important for a fresh graduate to become a better engineer. So these are the requirements of the industry that complete my presentation. So if you have any other questions, just let me know. I would love to answer those questions. Thank you very much.
Thank you very much, sir, for that insightful session. We have obtained a lot of idea about how to enter the industry. So, as told by engineer Dasun, I would like the audience to ask questions if there is any. You can use the Zoom chat itself. Also, you can feel free to turn on your mics or videos and ask questions if there are any. And we'll allocate time for you. Please ask questions, and we'll please use this opportunity to its most maximum potential. Sir, there was a question. I'll ask them. What is the question is? Let me read it. Yeah. To shift from conventional power to renewable power, reactive power, short circuit current, and frequency stability are all reduced when large conventional rotary generators are removed from the grid. So how do we manage this issue?
Can you raise that question once again? It's not that much clear to me.
To shift from conventional power to renewable power, reactive power, short circuit current, and frequency stability are all reduced when large conventional rotary generators are removed from the grid. So how do we manage this issue? When rotary generators are removed from the grid, conventional generators.
Correct.
Yeah.
Actually, this is one of the major issue that the planning engineers are currently facing. There's a lot of resistance. There's a lot of pressure from a lot of groups to introduce renewable energy to the system, especially the solar PV. But unfortunately, still the planning engineers and the design engineers, they are still struggling to absorb all the renewable energy to the network, reducing these large conventional rotary generators. This is exactly what has happened in the power in the last blackout. Actually, when the Kerala power grid substation tripped, around 160 megawatt of power is removed from the network because the Kerala power plant is tripped due to this. And at the same time, the Norachole line got tripped, and the 900 megawatt of power is removed from the entire network. So because of that, the entire network went for a blackout. And what has exactly happened after that, when the CB wants to power up the network, they were facing a lot of issues because of this renewable uncontrollable renewable energy that is generated to the rooftop power plants, small rooftop power plants. So they were struggling until the sun go down, and then only they could get the network up because of this renewable energy. So to manage the renewable energy in the system, that is of course a challenge at the moment.
Yes, thank you very much, sir. Adding on to that question, your video is not visible, is it, sir?
No, it's on.
Okay. Okay, sir, no problem. I think it's something with my camera. Adding on to the previous question, sir, is adding high capacity battery technology to the grid as to mitigate that, is it a good substitution a good solution for the problem with the loss of not having rotary generators in the system?
Well, I'm not an expert to explain you that give you a right answer to that question. But what my understanding is, yes, battery technology is going to be the next power source in most of the networks, because right now it is not be economical at the moment, but in the future, when the price of the battery system come down, when it combined with the solar power solar network, solar power projects, definitely it's going to add a lot of flexibility to the network, because right now, because of the intermittent nature of solar plants, you cannot control the system when the large solar is connected to the national grid. So, but when large battery storage is connected, definitely that problem is going to be sorted out. So my view that will be definitely one of a possible solution in the future when it becomes economical.
Thank you very much, sir. There's some other questions as well. There's another question. Is there a special mechanism to store electricity in a grid substation?
Well, a grid substation is not a place to store the energy actually. Grid substations are constructed to distribute, to basically transmit the power, right? Maybe to step up or step down and connect different substation, and mainly to build the network. So, but however, this energy storage mechanism, this, as I said earlier, the battery storage will be one of the good energy storage in the future. But apart from that, there are so many other technologies also under discussions, like hydrogen storage and hydrogen storage and these battery banks. So once those technologies become more economical, definitely those will be used in most of the network, so that it gives a lot of flexibility to take renewable energy to the network.
Thank you, sir. Moving on, another question. What is the role of an electrical engineer in construction of a substation?
I think I have made it clear that electrical engineer is the key person of a construction of a substation. In the project management unit, in construction of substation project management unit, most of the time the project manager is an electrical engineer, because there are a lot of equipments are there, so they have to coordinate with the design team, and there are a lot of systems that they have to do the design evaluation when the contractor submit you. And even in the contractor side, there will be a lot of electrical engineers involved to do the designs, to do the erection of equipment, and also to do the commissioning and testing and commissioning work of such equipments. So those are the activities that electrical engineer has in a grid substation project.
Okay, sir. There's another question. When we design a microgrid for a selected area, what are the suitable ways to collect the necessary data of the area for simulation?
Can you repeat that question once again?
When we design a microgrid for a selected area, what are the suitable ways to collect necessary data for simulation purposes?
Right. When we design a microgrid, okay, this question I think might have raised for a simulation purpose.
Yes.
Right. when we design a microgrid for a selected area, what are the suitable ways to collect necessary data of the area for simulation? I'm sorry, that question is not that clear to me. Suitable ways.
Move on to another question. There are 220 and 132 kilovolt and 132-33 kilovolt grid substations. What about higher order substations for high energy demanding places like Port City, Hambantota Industrial Square, etc.?
Right. So basically, when the planning engineers are planning the grid, so they consider the capacity, the energy demand of such projects like Port City. The Port City, they have connected the Port City to the grid the national grid using a 220 kV and 132 kV substation. And so that is mainly that they designed that network using the softwares that they have, mainly analyzing the load requirement, load flow, likewise. And if there's a requirement for higher voltage, when the national grid is getting bigger and bigger, even in the current context also, the Ceylon Electricity Board has floated a tender for a 400 volt substation, which is being under construction. So, but at the moment, the system is only going for 220 kV and 132 kV. But in the future, when the system becomes bigger and bigger, definitely we have to move for the higher voltage as well.
Okay, sir. Thank you, sir. There's another question. It's a question that I even have. What are the software and hardware prerequisites for freshers in the electrical and power industry? We currently learn about MATLAB and PSCAD and so forth. What are the key requirements for a fresher from the university?
Yeah, so basically the industry which I explained, the power industry, as I'll explain you, there are so many softwares that we are using, especially when it comes to planning, design, and testing and commissioning. So those are PSSC, PSCAD, and there are so many design software like ETAP are being used. But I don't think it is a prerequisite for a fresher to know such softwares, but it definitely it will be a added qualification for a person if they know such softwares. Then, but at the same time, softwares like AutoCAD is a kind of a prerequisite, because that is like a basic software that we expect a fresher should know.
Okay, so thank you very much, sir, for that insightful answer. That's it for the collected questions that we had. If there are any other questions, you can unmute your mics and ask or put a question in the chat as well.
I got a question. Hey, Dasun, my name is Samita and I'm a very old friend of you.
Hi, Samita.
And thank you very much for your insightful presentation. I just wanted to ask, you know, the system is ever evolving and the demand is raised. Is the planning division in Ceylon Electricity Board and the associated government bodies doing enough work to cater for the future demand, or are we at a beginning of a crisis, according to your experience?
Yeah, it's a broad topic that we should discuss with, I think even Navodana can support, because he's from Ceylon Electricity Board. But Now, actually, the planning divisions of the Ceylon Electricity Board, they have been planning the generation and transmission based on the government policies, right?
Yeah, that's right.
What happened is when the new government comes to power and they suddenly change their policies, then, as I said earlier, putting up a new power plant, it will take minimum 5 years, right? So it is not a one-day job that you can do all the things and bring down a power plant in 1 or 2 years. So it takes 5 to 6 years to construct a major power plant. There are power plants that they can power up within a short period, like the diesel engines that usually government has to bring because of these power shortages. So with the current context, yes, you are right. We are heading towards a power crisis. If there is a drought in Sri Lanka, definitely there will be outages in the country, because when the drought, severe drought is there, the power generation is not sufficient to cater the power demand in the network. So there will be definitely outages. But at the same time, now there are a lot of initiatives has taken to put up new power plants. I think already the Kerala PTA power plant construction is in the process of starting its construction, and there are several other tenders has been floated. So if we are lucky, we will be able to get those tenders finalized and award to a contractor, because there are some instances the tenders being floated, but sometimes due to some political pressure or some reasons, those tenders were cancelled. So again, if such a thing happens to the current tenders also, definitely we'll be facing such trouble in the future. But at the same time, there are people who wants to delay those projects and try to bring down emergency power so that they can get a profit out of that. But I know the Ceylon Electricity Board is really working hard to stop such motivations and try to go as per their generation plan and implement that plan. So that is their plan. So my answer is yes. If we do not construct the Kerala PTA, the Kelnathis, then definitely there will be a power crisis in the future.
Thank you, Dasan.
Thank you, sir. Engineer Dasan Narandara, I have a question as well. It's about what are the consequences if your company gets approved for a tender, and if you don't deliver, what are the consequences there are to that company? And
yeah, actually there are the first thing is there is a financial consequence, because when we submit a tender, we have to submit the tender with a bank guarantee, right? So if we do not honor the letter of award, definitely the client has the right to encash the bank guarantee that we have submitted. Right? There are cases, because sometimes the contractors, they do wrong calculations, and if they go ahead with the project award, then they will be getting more losses than they get then the client encash their bank guarantee. So in such situations, the construction companies, sometimes they give up the bid because of such a mistake they do. But yes, if they do not honor, the client is always alive. There's ability to the client to encash the big guarantee of the bid submitted along with the bid. And apart from that, even after the bid is awarded, once we sign the contract, we submit a performance guarantee value more than that. Usually the big guarantee is around 2% of the total contract value. The performance guarantee is around 10% of the total contract value. So once we submit the performance guarantee only, the client allow us to start the construction work. And to take the advance, we have to provide the 10% advance guarantee. And based on that, the client gives you the 10% advance usually. So if we stop at that point, definitely the client has the ability to encash the performance guarantee and recover the losses that they have incurred and the delay losses due to the delay of the project. I hope I made it clear my answer.
Yes, the answer was pretty clear, sir. Thank you very much. Before going to further questions, the link for the feedback form will be put on the chat on the Zoom chat. Please take your time and fill that form and give us your feedback about about today's session, so we can improve upon our mistakes and deliver you a much better experience next time around. So are there any questions from the audience? It's time for you to ask them.
Sir, I have a question for you. Actually, sir, I want to know what are the classifications of the substations according to the design?
Well, you asked about the specification, Anilusha?
The classifications, sir. About
what do you,
yeah,
what do
I'm
you mean
asking
by
you the classification. Sir, I mean, I'm asking about like what are there any sort of classifications happening in the substations according to the design, or like how is it happening?
Well, it's like this. Now, based on the technology and based on the voltage level, the substations are classified into several categories. Like now, the substation with 132 kV level or higher voltage, those are classified as grid substations,
Okay,
right? And the low voltage like 30 kV or 66 kV or the 11 kV substation, those are classified as primary substation or distribution substations. At the same time, based on the technology that they use, we can classify the substation like gas insulated substation, GIS substation, and AIS substation. Like now, if we take the Kerala PTA substation in Sri Lanka, that is a gas insulated substation, because the 220 kV side, all the equipments are in a gas insulated switch gear. Circuit breakers, ETs, VTs, bus bar, everything is enclosed in the gas insulated switch gear. Even the 30 kV level, the switch gear is also gas insulated. So those gas insulated, those substation with gas insulated switch gears, we can classify it as GIS substation. And the other one is the air insulated substations. I hope I give you a reasonable answer.
Yeah, thank you, sir. Thank you so much.
Sir?
Yes.
Yeah, I also have questions, sir. So what I want to know is, so what are the factors to be considered for selection when it comes to a selection of a site and outdoor type substation?
Navadan, I think you can give a good answer for that question. Navadan is a project manager for a project, so I think he'll be able to give a better answer than me. Navadan, would you like to answer that question?
Okay, that's my question was how we select AIS and GIS, right? As I understood.
Yeah. When it comes to its outdoor type substation.
All right. Okay. Good. Now there are two main options. We can go for outdoor or indoor. Why we are going for outdoor or indoor? The thing is, main reason is once we are connecting transmission lines, there are two, the overhead line or underground line. Normally, we are putting underground lines for urban cities like Colombo. We are going to underground is having so we have to go like that. And contested area, if we put outdoor type grid substation, we need a lot of space.
Excuse me, sir.
Yeah, installation.
So I think there is some
Hello?
connection issue or something.
Yeah, I think line is
Can't
not
hear
clear
you.
now. Then.
Right.
Yeah.
Is it okay?
Yeah, Pesha, let me answer your question. So basically, as Navodana was explaining, now based on the site requirement, okay. Now, if we consider a project in urban city like Colombo, the space requirement, the space availability is very less, right? If we go for AIS substation, if you compare the space requirement for AIS substation and GIS substation, there's a 40 to 50% space reduction in GIS substation. So for a project in the urban cities like Colombo, usually actually this activity is done by the planning and design team. They identify, okay, what is the land value of that particular area, and they see, okay, what is the most economical technology for a such project, right? So when they are identify the lands, they consider that, but at the moment they know, okay, for a Colombo, it definitely it is most feasible to go for a GIS substation, because there is no big lands in Colombo that we can use for a grid substation, right? So we are constructing a substation in Habarna. The land size of that substation is 17 acres, right? So it's a huge substation. But if we want to, it is also very much similar to the sub L in the port, right? I don't think the sub L is 1/4 of the Habarna substation that we are constructing as a AIS substation. So that is one of the major reasons that they consider the land value. And the other thing is the pollution, right? The quality of air, right? There are instances if we put up a substation in the coastal areas, there are a lot of nuisance stripping because of the salty condition of the air. So to avoid such situation, most of the time people, the planning engineers, design engineers, they go for a gas insulated switchgears in those areas. So these are the factors that usually considered for the designing, considering gas insulated or air insulated substation.
Okay, thank you, sir.
So I also have a question. First, I want to thank you for the informative session today. And my question is, what are the cost-effective solutions for the offshore wind market?
Cost-effective solution for offshore
Wind market.
wind mass.
Wind market.
Wind market. I'm sorry, Pasan, I might not be able to give you an answer because that is not my area of specialty. Well, actually, I have very limited experience in offshore wind market.
Okay, sir. It's okay. Thank you.
So the recent trends and concepts when it comes to engineering projects like electrical engineering projects.
What are the recent
trends and concepts like?
Yeah, the recent trends are like now when these solar projects are becoming more economical, there are a lot of renewable energy projects being carried out in the country. Even the Ceylon Electricity Board, they have come up with a lot of tenders to absorb new renewable energy to the network. And at the same time, when because the battery technologies are getting more economical, these microgrids concepts are now coming to the country. And we are currently constructing a microgrid pilot project in University of Moratuwa with the support of ADB, and the client is LECO. And so definitely that type of technologies will come in the future when the battery technologies are getting more economical, right? And at the same time, world leaders, multinational companies like Siemens, ABB, and Gamesa, they are doing a lot of R&D on hydrogen technology as well, hydrogen storages, and so that they can store the electricity energy in hydrogen manner, right? So that they can transport those hydrogen. They can use the hydrogen in the basically transport sector as well. So those technologies will come in the future, but near future, I am pretty sure that this microgrid solution will be popular in near future.
Okay, sir. Thank you, sir.
You're welcome.
So I also have a small question.
Yeah.
As a developing country, what is the development status of grid substations construction and commissioning?
What is that?
As a developing country, what is the development status of grid substation construction and commissioning?
Development status means
the development status of the grid substation constructions and commissioning.
Sorry, I'm not clear with it.
The development level from time to time in grid substation constructions and commissioning. As a developing country, what is the development status of grid substation construction and commissioning? Grid substations wala construction and commissioning wala ඒ කියන්නේ අර ඉස්සරහට යද්දී අර අපේ development status එක දැන් අපේ ලංකාව දියුණු වෙන රටක් විදිහට.
All right, okay. So sorry, I didn't get your question first. So basically, even though Sri Lanka is a developing country, Ceylon Electricity Board, they are in a very developed stage actually. When compare with the developed country, they are very open to bring down new technologies to the country, right? Now there are a lot of new technologies like smart grid. They have a very good system control center, and all the substations that they build, that almost all the substation currently being built, and even the future substation, it has a SCADA system in those grid substations. So there are a lot of latest technologies being used in Sri Lanka, even though Sri Lanka is a developing country. Very recently, they have put up a variable shunt reactor project. Currently, that project is also under construction. Mainly now, when the Mana 100 megawatt wind plant is connected in the Mana area, there are very less power plants in that area. So because of that, there are a lot of voltage rise in that line. So to compensate that, the Ceylon Electricity Board has gone for a latest technology and installed a variable shunt reactor in Anuradhapura and Mana. so that they can absorb a lot of new renewable energy in that area, because the Ceylon Electricity Board, they have planned to absorb around 350 megawatt of wind in Mana area, and at the same time in the northern area there are a lot of solar parks they have planned. So for those absorption, they have gone for latest technologies. So likewise, I think my gut feeling is that Ceylon Electricity Board, they have done a lot of, they have introduced a lot of latest technologies in their system.
Okay, thank you, sir.
Thank you very much, sir. There is another small question from me. What I want to ask is it sustainable and is it wise to go for renewable energy straight away, as we run a lot of our energy share on coal power and hydropower. So when there is more than 900 megawatts, yeah. So when we go forward for renewable energy, is it wise to go that quickly? Because it will be more costly for Sri Lanka, as it's not, it is in the developing phase.
Well, it's like this. Now, when I show you the energy mix in my presentation, you might have seen that, okay, it is not overnight you are putting all the renewable energy. It is not possible, right? If you do that, definitely the system stability will be affected, right? So then we'll be having a lot of outages in our national grid. So that is not the way that it has to be done. And at the same time, we have to increase the renewable energy composition in our energy mix. And the government is planning to increase it to 100% by 2030. So there are technologies in the world still being developed to go for such type of 100% renewable energy powered grid. But at the same time, there should be a lot of development in the renewable energy also, like the battery storage. If the battery storage is developed, become economical, this intermittent nature of the renewable energy will be somewhat managed, because the battery storage can definitely act quickly and give power to the network without voltage variations in the network.
Yes, sir. Thank you very much, for these answers. I think everyone got an comprehensive answers for their questions. Are there any more questions, or we can wrap up the Q&A session? If there are any more questions, you can ask. Okay, it seems there are no more questions. Thank you very much, sir, for giving us this wonderful opportunity and educating us on how to prepare for designing, planning, and it's been a very wonderful session. So we have to end this Q&A session because we run on a time constraint, and we gave you a lot of questions and you gave much comprehensive answers, and we really thank you for that. With that, before we conclude the webinar, I invite you all to turn on your video, and we'll take a small photo as the next generation of engineers in Sri Lanka, and bridge that generations together. Please turn on your video so we can take a photograph. Everyone who are able to, please turn on your cameras. Give me a minute. Is that all? Okay, then let's take the photograph then. I'll count to 3 and let's take the screenshot. 1, 2, and 3. I think the screenshot has been captured. Is it okay, Lakshmi? Everything good? Okay. So with us today, before we conclude this webinar session, I cordially invite the Vice President of the Electrical Engineering Society of University of Moratuwa, Mudita Senaviratna, to deliver the vote of thanks. Hello, Mudita.
Hello, everyone. On behalf of Muditaya, I would like to deliver the vote of thanks. I'm the Assistant Secretary of ESOC. So, hope you all doing well and staying safe. So here successfully concludes the second episode of the Inven webinar series, giving us a vast knowledge on engineering projects, designing, planning, executing, and commissioning. Actually, this topic itself tells us what the industry is all about. So I strongly believe that this knowledge will be a great asset to all of us when we expose to the industry and begin to work in it. So on behalf of ESOC, Electrical Engineering Society of University of Moratuwa, I would like to extend our sincere gratitude to Engineer Dasun Narandarage for dedicating your valuable time to enlighten us on one of the most important as well as a timely topic. And thank you, Engineer Navodana Kankanamge, Dr. Asara and Dr. Tushara for your constant motivation and guidance throughout this event. And a huge thank you goes to the organizing committee of this event. You guys made it a huge success. And of course, we had an enthusiastic audience. There were many students filled with curiosity asking different kind of questions. So thank you all for your active participation. Hope you all join in the upcoming sessions too. So thank you. Good night and stay safe.
Thank you. Good night then.
Thank you, Roshanaka, for thanking us, and thank you, dear sir, for giving us this opportunity. And it's been a wonderful day. So now we are hereby concluding the second episode of the Tech Talk webinar series. With the hope of meeting you all again with a third session, I'm signing off. I'm Jayanaka Dantanarayana. Stay safe and good night. Thank you very much, sir.